Hello everyone, welcome. My name is Chao Yang. I'm a Senior Industrial Solution Manager at Huawei and your host for this session. The information and communication technology have experienced a round of booming in the telecom industry. The growth and values of AI, big data have brought great value to the IT world, especially the online commercial marketplace. Traditional industries such as our electric power industry, stakeholders are all looking into strategies of building new ICT, AI, big data capability into their company's capability profile. I'm very privileged to have this opportunity to invite Mr. Gu Yunbo first to speak on next generation power communication solution. He will bring us the most advanced technology for communication for electric power utilities. These technologies will be the foundation for connecting the future smart grids.
Hello, my name is Yunbo, Vice President of Huawei Transmission and Access Enterprise Domain. It's my great honor to present next generation power communications network solution. The electric power industry is now digitalizing its OT system. This means a larger scale in producing traditional and clean energies, increasing automated devices and surveillance devices, and more exchanges of OM data. Some enterprises have even launched new operation service. At the center of the electric power communication system, the power transmission and transformation communications network is facing new challenges. First, providing security for production automation and operation. For example, teleprotection requires dedicated paths to ensure high reliability and low latency. Second, delivering system compatibility for different service interfaces. Third, handling 100 times more traffic due to the digital office, new service operation, and cloud-based data center construction. Fourth, managing the scale development of distributed power generation and longer distance of EHV power transmission. In the past, PDH and SDH supported the informatization and automation phases respectively. Now, liquid OTN is the best choice for next generation power production. Like previous technologies, liquid OTN has physical isolation, optimal latency, and perfectly suit production devices. What's more, it provides more scalable bandwidth. Liquid OTN offers a secure, reliable, efficient, scalable, and energy-saving guarantee for production communications. What's liquid OTN? Liquid OTN is the next generation hard pipe transportation technology inherited from SDH, providing highly secure pipes for OT networks. In addition, liquid OTN is an advancement based on SDH. First, simplify the service mapping path. Traditional SDH service mapping paths at least 3 layers. Liquid OTN only needs 2 layers. So, the latency of a single site is reduced to less than microseconds. Second, adopting converged barrier technology. Liquid OTN supports 2 megabit to 100G any-rate interfaces, reducing device tips and simplify network layers, discounting TCO by over 30%. In addition, liquid OTN provides hitless and lossless adjustment from 2 megabit to 100 giga, reducing bandwidth fragments and improving utilization to 100%. SDH only provides 10G bandwidth with a single fiber. By using liquid OTN, a single wavelength can provide 100 giga and above. A single fiber can provide more than 48 terabit. With insights into the electric power industry and optical technologies, Huawei develops a simplified, secure, and smart communication solution based on liquid OTN. This solution offers a 4-in-1 platform that adapts to multiple scenarios, in addition to old and new interfaces. It integrates the traditional production, office, and bandwidth operation networks, reducing TCO by 30%, and these services are physically isolated to guarantee security. Moreover, solution inherits SDH mature achievements, including hard pipe and ultra-low latency, so that to guarantee teleprotection working safely, the 450 km single span can and intelligent unified O&M reduces hardware investment and improves overall O&M efficiency. A power communications network carries production services such as teleprotection, SCADA, dispatching telephone, video surveillance, information storage, and data center interconnection. Its rate ranges from 64 kbit to 100 giga. Traditional multiple types of devices are stacked, and the transmission devices such as PCM, SDH, packet, and OTN are used to carry production signals. To address this, Huawei's new liquid OTN platform provides unified service switching capabilities by integrating SDH, packet, and OTN cross-connect plays. Varied service boards support different services, and the intelligent universal line boards implement universal transmission. This means the capabilities of multiple devices are integrated into one. As such, device management is simplified. Cabinet space is saved by 70%, and the device power consumption is reduced by 50%. Overall, this means that the TCO can be reduced by more than 30%. OT networks have high requirement on security and reliability. For teleprotection, if a system fault is discovered, faulty components must be removed automatically, quickly, and correctly. In this way, damage to power components and the impact on system security are both minimized. Liquid OTN is a hard pipe technology, similar to SDH. Compared with IP soft pipes, hard pipes provide dedicated bandwidth to carry signals. This means there is no interference between pipes. In addition, low latency is guaranteed, deterministic, and visualized in an end-to-end manner. This ensures high security and a reliable response of OT network services. As a leader in the optical industry, Huawei introduces ultra-long-haul transmission technologies to electric power networks. With high-rate optical modules and unique CMS algorithms, Huawei delivers 20% longer transmission distance compared to the other vendors. In fact, the transmission of a single span can reach up to 450 kilometers. This perfectly matches site deployment and maintenance in unattended areas, such as deserts and forests. The next generation power network solution based on liquid OTN perfectly matches various application scenarios and challenges. The 4-in-1 interfaces can access narrowband, HD video, and high-speed Ethernet data. Hard pipes ensure low latency, stable reliability, and security for transmission networks. The ultra-large transmission capacity provides bandwidth support for new O&M and operation modes. Superb transmission performance effectively reduces UHV O&M costs. Huawei's liquid OTN-based OptiX Trans series covers the power backbone, transmission, and access network scenarios. The OptiX Trans E9600 series support 24 service slots and 48 T per fiber, making it suitable for backbone network transmission. The OptiX Trans E660 series features small-sized case-shaped products with reduced power consumption. They support AC and DC power supply and are easy to install and deploy, meaning they are applicable to metro aggregation and access scenarios. The next generation power communications network solution based on liquid OTN will usher in a new round of development in the power industry. Now, let's witness this historic moment. Thank you.
Thank you, Mr. Gu. It's exciting to see that liquid OTN as the next generation communication technology, providing 99.99% ultra-reliable communication for future smart grids, a 10 microsecond low latency, and a 450 kilometer direct connection. Next, let me invite Huawei's customer to share with us their experience adopting the intelligent OptiX network solution. Daviat is an integrated telecommunication and information technology company owned by Saudi Arabia Electric Company. Let me first invite them to share their insights. Next, let's speak to National Grid at SCC. National Grid is responsible for operating and maintaining the power grid at Saudi Arabia. Let's hear what's their experience of using the OptiX network solution.
NG is solely owned subsidiary of SEC, responsible for power transmission and transformation services of more than 1,100 substations.
NG has made remarkable strides as driving force of global smart grid initiatives. Resultantly, NG has one of the largest fiber optic network in the region with coverage more than 70,000 kilometers. Network bandwidth usage up to 8 terabytes. In the road of these developments, we choose to work closely with Huawei to achieve fruitful results in the power grid ICT field.
NG was established in 2012. It has completed optical fiber architecture deployment during the past years, initiated network development and deployed huge optical network to provide the highly reliable telecom services for efficient operation of transmission network. NG strives to continuously improve and optimize production services, simplify the network bearer architecture of production services, and implement the transformation from TDM to packet networks that carry multiple services in a unified manner. As a leader in the ICT industry, Huawei has provided NG with a complete and mature technology evolution direction.
Huawei is among the first vendors to initiate the evolution path of ICT in National Grid Saudi Arabia. Our smart grid vision is focusing on digitally enabled infrastructure, in line with the global trend in grid modernization and business transformation.
As a corporate-level strategic partner, Huawei also continuously support on knowledge transfer by conducting workshops, technical seminars, certified training, and joint innovation lab to align with National Grid's talent development strategies.
Today's Saudi Arabia, a country moving forward to become the heart of the Arab and Islamic world, is the investment powerhouse and the global hub connecting 3 continents. This is the Vision 2030. The National Transformation Program 2020 was launched to support the vision by developing governmental work and establishing the needed infrastructure. Saudi's digital transformation agenda is to build a fully connected, intelligent world in which every citizen can experience the best connection service. To achieve this, Saudi Arabia has 3 initiatives: 100% connection service coverage, 4G in rural and distant areas, and FTTH. Saudi Arabia has achieved a 100% connection service coverage throughout its grand territory and population by July 2018. Citizens can now get connected and keep up with the ever-changing world, even in the most distant area. Saudi Arabia is ambitious to build a fully connected, intelligent society by providing citizens with fastest internet connection, fiber. Fiber's connection is 10 times faster than 4G connection.
Dawiyat is a very unique company. It has been licensed by CITC, the Communication and Information Technology Commission in the Kingdom of Saudi Arabia, to offer wholesale services to the various operators, the various infrastructure telecommunication providers in Saudi Arabia. The Saudi Electricity Company has actually now surpassed 75,000 kilometers of fiber placed in the Kingdom of Saudi Arabia. This network is not only vast, but very robust.
Fiber connection will greatly enrich people's internet experience, bring new business models into reality, and boost the digital transformation of the country.
I think this is a fantastic step to take the telecommunication sector in Saudi Arabia to a new higher level.
The country is ready for future development. The next step towards 5G, IoT, and AI is on the way. In a fully connected, intelligent Saudi Arabia, innovation will be catalyzed and new potentials will be unleashed. Every person, group, and family will be able to fulfill their dreams and ambitions.
Now let me invite Mrs. Yang Hongzhen to share with us the topic of new OTN optical transmission technology helps build a converged elastic grid. Mrs. Hongzhen Yang is from State Grid Corporation of China, who is the Director of the Technology and Development Department.
Hello everyone, I'm Yang Hongzhen, Director of the Technology and Development Department of Zhejiang Electric Power Company of SGCC and Chair of the IEEE P2893 Working Group. Today, as a power industry practitioner and technical standard participant, I'm honored to share with you new OTN optical transmission technology helps build a converged and elastic grid. First, let me introduce Zhejiang Electric Power Company of SGCC. It is a wholly owned subsidiary of State Grid Corporation. It is tasked with building and operating the power grid. It is responsible for ensuring a safer, more economical, cleaner, and sustainable power supply. It is a key enterprise in the energy field in Zhejiang province. This company directly manages 17 units and 78 power supply companies, including 11 city-level and 67 county-level power supply companies. Its power supply services cover 56 million people in the province. The company has 57,000 kilometers of 110 kilowatt or above transmission lines and 433 million kilowatt ampere substation capacity. 1,000 kilowatt substations have been built, and the substation capacity reaches 18 million kilowatt ampere. It has deployed the world's first 500 kilowatt cruise-linked polyethylene submarine cable. Looking into the future, Zhejiang Electric Power Company plans to basically build a world-class modern energy enterprise with outstanding competitiveness by 2025, with the company's asset quality, operating performance, and service quality reaching the world-class level. By 2035, we will build an absolutely leading modern energy enterprise with outstanding competitiveness. The company's value creation capability, market competitiveness, and brand influence will reach the world-class level. In recent years, with the rapid economic and social development of Zhejiang, the demand for electricity continues to grow. The peak power consumption of Zhejiang reaches 92.68 million kilowatts, an increase of 8.82% over last year. It is estimated that this number will exceed 100 million kilowatts by 2021. With the growth of the peak power consumption for many years and due to power volume increase and power price decrease, the traditional model of expanding the scale to meet the growth of electricity demand is no longer workable. In Zhejiang province, there are 13 types of power supplies. Substation sites and line corridor resources are increasingly insufficient. However, there is huge potential for utilizing existing corridor resources. The power supply and power grid sites are trying hard to meet increasing power consumption demand, but users are not fully engaged. The energy storage side is constrained by the lack of conducive policies. Power generation, grid, load, and storage are not effectively linked. Market access, trading, and settlement mechanisms need to be improved. Power supply adjustment capability is decreasing. Security red lines are tightening. Load interaction mechanism is not mature. Energy storage facilities are insufficient and difficult to use. Power grids are facing problems of lack of interaction between generation and load, redundancy for security, decreasing balancing capacity, and lack of efficiency improvement methods. Therefore, traditional power grids need to transform towards flexible generation grid load storage interaction. Transform the power grid from load-based generation to generation load interaction, from redundancy for security to reduced redundancy with security, from power balance to electricity balance, and from efficiency reduction for security to improved security and efficiency. In the strategic framework of the state grid, we propose to build a converged and elastic grid for the energy internet. The purpose is to improve the traditional generation grid load storage model and support the grid to transform towards energy internet, which is based on big data, cloud, IoT, mobility, AI, and blockchain technologies. It aims to improve power grid security, operation efficiency, and overall energy efficiency by using technologies and market factors. A converged and elastic grid is key to the energy internet. Align energy production with transmission, distribution, and consumption, enable efficient interactions, jointly activate underutilized power resources with customers, promote the transformation of power grids towards energy internet, involving users in load adjustment. That will greatly reduce inefficient power investment and energy consumption costs. To build a converged and elastic grid, technical enablement is an important implementation path. With 5G, optical connectivity, and IoT sensing technologies, power production, transmission, and consumption can be aligned. Use IoT, big data, AI, and other new technologies to build power IoT and cloud computing platforms to support diverse internal and external power service applications. Enable power grids to have high bearing capability, high interaction, high self-healing, and high efficiency. In the entire architecture, power information communication supports the control, management, and applications of smart grids and is the core element of the converged and elastic grid. Therefore, with the transformation and development of the electric power industry, information communication also needs to be upgraded to meet the requirements of grid construction and development. Currently, the power information communication network is seeing a sharp increase of power grid service traffic. First, increasing new energy and services. Solar and wind energy and other types of new energy is integrated to the network, increasing distributed power generation and storage. More digital technologies are applied in production, such as environmental monitoring, unattended operation, and IoT sensing, provide new power services for consumers such as charging piles and the smart home. Second, extending the control capability, expand from power transmission and transformation control to power distribution, distributed power supply, and power consumption control. The number of control points increases from hundreds of thousands to millions. Quasi-real-time control is enhanced to real-time control, and the control frequency changes from low to high. Third, explosive growth of data. Data collection points and collected data volume are increasing significantly. Data collection frequency and timeliness are improved. Meters and charging piles interact with the power grid, and the demand for massive data exchanges increases sharply. For example, by 2021, state grid is expected to have over 1.2 million small charging piles. By 2025, over 1 billion devices are expected to be deployed. The daily incremental data collected on the entire network is expected to exceed 100 TB. As power grid service transformation leads to a sharp increase of information flows, the optical communications private network faces challenges posed by the power industry and the technology industry. For example, in the electric power industry, first, high security and reliability are required. The communication network must meet the national information security protection level, and the reliability must reach 99.999%. The requirements for relay protection are even higher. Second, the demand of diversified service services must be met. The communication network must be able to carry traditional production dispatch, control, and monitoring services, as well as IoT sensing and data center services. Third, ultra-high bandwidth is required. The information traffic connected by massive devices on the entire network can reach dozens of TBs after being aggregated to the backbone network. From the technology industry perspective, due to bandwidth bottlenecks, traditional SDH technologies are unable to support digital information services. The SDH industry is shrinking, and older processing techniques are phasing out, and the entire communications industry is upgrading. The current OTN technology lacks small granularity capabilities. Bandwidth utilization is low. It cannot efficiently carry low-speed services and cannot meet latency requirements of key services. Therefore, the electric power optical communication is calling for a new technology. Through research, we believe that OSU Flex is the primary choice for power communications private networks. OSU Flex inherits the roadmap and the development direction of the traditional TDM technology, adding SDH technology features to the existing OTN technology. In addition, it inherits the technical strengths of SDH and OTN optical communication private networks, including small granularity service encapsulation such as 2 megabit per second, ultra-low latency assurance, 200G BPS bandwidth that supports expansion similar as OTN, and a unified bearing capability, one platform, one technology platform for multiple services, including PCM, SDH, and packet services. OSU Flex inherits the features of SDH and OTN. It inherits the feature of hard pipe physical isolation. Services of different systems can be transmitted through independent pipes. Services are not interfered or attacked. In addition, it inherits the small granularity feature of SDH. OSU Flex technology can support smaller granularity lower than OTN's 1.25 gigabit per second. The minimum granularity can reach 2 megabit per second, the same as that of SDH. Therefore, the right bandwidth can be provided for services with different rates, improving bandwidth utilization. Third, to improve latency performance, OSU Flex optimizes the service encapsulation process compared with the OTN's 5-layer encapsulation process and SDH's 3-layer process. The 2-layer encapsulation capability enables better latency performance. OSU Flex has the strength of both SDH and OTN. It can provide bandwidth of 2 megabit to 100G. The minimum bandwidth and adjustment step can be as small as 2 megabit per second, which can enable high bandwidth utilization. A single 100G channel can be sliced based on the size of services to be carried to meet bandwidth requirements. For example, relay protection services that require real-time control in power production, RE1 services, and require 10 millisecond latency. OSU Flex provides 2 megabit dedicated pipes, and the latency can be shorter than 10 microseconds, so it can meet the 10 millisecond latency requirement of relay protection services. For example, video surveillance services do not require strict latency but require high bandwidth scalability, so configure high bandwidth OSU Flex channels for those services. Currently, several enterprises, including Zhejiang Electric Power Company, are researching on new power communication technologies. Huawei is also investing in R&D in the same direction to promote the standardization of new OTN technologies in the power information communications field. Zhejiang Electric Power Company, Huawei, China Telecom, Power China, and Siemens jointly promoted the initiation of a project in IEEE. After about 8 months of efforts, the IEEE officially approved the project initiation. The project number is P2893. In August 2020, the project kickoff meeting was held, making a solid step forward for the development of power information communications. To promote the standardization of the new OTN technology in the power information communications field, Zhejiang Electric Power Company will work with project team members and partners. The company plans to test and commercially verify the OTN technology in multiple electric power application scenarios to provide solid case studies and data. The new OTN technology is used to build a converged and elastic network, create a secure, high-barrier, self-healing, and high-efficiency private network. Here, we call on more electric power companies to participate in this technology innovation and work together to convert the Chinese technology into an international standard. Thank you.
Thank you. Thank you, Mrs. Yang. As presented and discussed by our honored guest, we are entering the next phase of communication technology for smart grid. We, Huawei, are gladly to be part of this wave and support our customers with the best technologies.